Hi, in this video I'm going to talk about how to approach a coding interview problem in theory. Because theory and practice can be very different, I made it in two parts. First part of the video is talking about theory, second part of the video is talking about practice. By theory, what I mean is that what is advertised or what you will find in books. There are many good books written about this topic, including Cracking the Coding Interview, Elements of Programming Interview, and Programming Interviews Exposed. They come with a lot of sample questions, also a way to approach a problem. What I have outlined here are the steps that you can take to approach any kind of algorithm data structure problem. Let's go through the steps one by one. Step 1. Ask clarification questions. This is very important because without establishing what is the problem at hand, what exactly has to be solved, it's very hard to give optimal solution. So think about things like, what is the size of the input? Is it only integers? Can it be characters? Do we know something about the input, as in, is it sorted? Is it only positive? Are there some constraints? Is it bounded? Or in terms of a string coming in, how long can it be? Is there a maximum size? Is it only lowercase? Can it also contain numbers? All these questions can provide two things. One is a hint towards the optimal solution, and the other is to establish it with the interviewer that you're talking about the same problem. Step 2 is to come up with a small example. And small, think about an input with a size like 3 or 4, because 1 is usually too trivial, 10 is going to take a lot of time. So the sweet spot is somewhere around 3 and 4. And this also gives ideas how to solve it later, and also it solidifies the understanding of the interviewer and yourself that this is the problem at hand. Step 3 is about coming up with a function signature, or in case of a class, it's also the outline, what would be the member functions, what would be the fields in the class. This is usually something that if you do anything like practicing online, this is already given, but in a real life scenario, it is not. So imagine that you go to, say, LeetCode, which is the most popular platform to solve these kind of problems. You already get a class and a function, and it tells you that this is the function you have to write. In a real setting, what you have to do is come up with the function signature yourself. What do we return and what do we get as an input? Step 4 is coming up with a trivially correct but not necessarily optimal solution called the brute force. So the brute force is something when it's very obvious that it is solving the problem, but it is not necessarily the best. In step 4, the goal is to solve the problem in any way as long as it's correct. And you don't have to worry about is it too slow, is it taking too much space. The only thing important here is that there is a solution, and then you can say that what is the runtime and what is the space complexity, because this is going to serve as a base for improvement. Step 5 is the improvement step. In this step, you're trying to improve upon the brute force algorithm that you came up with in step 4, either in the space complexity and also on the runtime. It's actually more important to focus on the runtime because the user only cares about the runtime. So if you have to spend more money to get more memory on the backend and the user is happier because the runtime is faster, then that is the thing that you should aim for. So it's not so much of a balance, it's more like you try to improve the runtime first and foremost, and if the space complexity can also be improved, that's that much better, but that's like icing on the cake. So that's why in this step it's a must to improve time complexity. You can think of many ways of improving time complexity, such as if you identify that there is a piece of work that is done twice, and is there a way to eliminate it, or can we pre-compute something, or for example, sorting the input is a time investment in the beginning, but maybe it will save a lot of time for the consecutive steps. So step 6 is to test the code. That's also very important because before you can say that you're done, you have to provide evidence to interviewer that why you think the code is working. And the best way to do it is to basically, first of all, use the small example that was generated in step 2 and plug it into the code that you wrote, say the improved brute force solution, and then if it's working on that one, then also try to generate a couple of edge cases to see if your code is catching them and handling them properly. And if it's all working, then you can move to the conclude step. So for this final algorithm, our runtime is this and our space complexity is that. And this is much better than the original brute force, and all the test cases that we could possibly come up with are passing, and we handle all the edge cases, and therefore you have to conclude that it is all good and you're happy and interviewer is happy. Alright, so to conclude this all, this gave you an overview of how you approach a coding interview problem in theory. In part 2 of this video, you will see how you approach them in practice. I will see you in the next video.